Hello and welcome to HP Gaming Garage. I am Professor Raja Ravichandra Prasad, Game Director at Artemisia College of Art and Design. The 8th module of game programming is Game Engine Unity Part 2. This module is a continuation of the 7th module, and I would highly recommend watching the previous module before proceeding with this one. As mentioned earlier, Unity is a preferred game engine. So in this module, we will try to master the concept that will enable a game developer to unlock a whole new level of gameplay. Over to you, Shreyams.
Thank you, Professor. Hello everyone, I am Shreyams and we will be discussing the module Game Engine Unity Part 2, curated by Professor Raja. Let's start by discussing what exactly Unity does and an overview of its features. Coordinate space. Imagine being able to accurately represent physical space using a mathematical system of coordinates. That's the power of coordinate space. It can be one-dimensional, two-dimensional, three-dimensional, or even higher dimensional, depending on the context. With coordinates, points in space are perfectly represented by ordered numbers. Take for instance a three-dimensional Cartesian coordinate system where a point can be represented as x, y and z, with each value representing the position along the x, y and z axis respectively. With this system, you can accurately plot points in space and take control of your data like never before. These points are vital in defining how objects are positioned and oriented in the game world. And guess what? They are closely related and often used together to describe the location and size of objects in a Unity 3D scene. World space. This global coordinate system is essential for defining the accurate positions and orientations of objects in the game. By establishing a world origin, you can easily define the absolute positions and orientations of objects without having to worry about any specific hierarchy or dependencies. This makes world space an incredibly useful tool for gamers and developers. Local space. Also known as object space, local space allows the developer to effortlessly define positions and orientations relative to each individual object's origin point. With local space, you can easily customize local rotations and translations without any hassle. Parent space. By using this incredible tool, the developer will be able to define the positions and orientations of child objects relative to their parents' origin. This allows for seamless and hierarchical transformations that are sure to take your projects to the next level. Screen space. Screen space in Unity 3D is the solution to all your positioning dilemmas. With the normalized screen coordinate system 0, 0 representing the bottom left corner of the screen and 1, 1 indicating the top right corner of the screen, the developer can easily create seamless and professional looking screen overlays. View space, also referred to as camera space or eye space. This cutting-edge coordinate system is an impressive tool for rendering and culling objects based on their visibility within the camera's view frustum. With its user-centric design, view space makes it easier than ever before to create incredible visual experiences and truly transport your audience into another dimension. Let's recap the various types of coordinate spaces. Coordinate space is a mathematical representation of a physical space using a system of coordinates. Points in the space are represented by coordinates usually as ordered numbers. In Unity 3D, coordinate spaces are used to define the position and orientation of objects in the game world. World space is the global coordinate system of the game world where positions and orientations of objects are defined relative to the world's origin. Local space refers to the coordinate system of any individual object where positions and orientations of objects are defined relative to their local origin. Parent space is useful for defining positions and orientations that are relative to the parent object's transform, allowing for hierarchical transformations. Screen space refers to the coordinate system of the screen or the display in Unity 3D where positions are defined in normalized screen coordinates. 0, 0 represents the bottom left corner of the screen and 1, 1 represents the top right corner of the screen. View space is useful for defining positions and orientations that are relative to the camera's perspective, such as rendering and culling objects based on their visibility in the camera's view frustum. Let's move on to discuss about vectors and quaternions. These powerful tools are key to manipulating object positions, orientations, and transformations in 3D space. With vectors and quaternions at your disposal, you will be able to effortlessly move, rotate, scale, and animate objects in your Unity 3D project. Vectors in Unity 3D. Imagine smoothly moving, rotating, and positioning the game objects like never before, with effortless precision and accuracy. Thanks to Unity's vector class, and in particular the widely used Vector3 type, the possibilities are endless. With X, Y, and Z float values, you will be able to pinpoint any point in 3D space with ease and confidence, accomplishing even the most ambitious game design goals. With vectors, the developer can create complex movements that will enhance the realism of your game, engaging interactions that will captivate the player's attention, and the ability to calculate precise trajectories for bullets and arrows. Imagine the endless possibilities of creating a jump mechanic with a simple Vector3 or Unity's built-in functions like Vector3.lerp to fluidly interpolate between two positions over time. Quaternions in Unity 3D. If you're a game developer looking to create smooth and realistic rotations for your game objects, then quaternions are a must-know concept in Unity. While they might seem complex at first, they offer several advantages over other methods of rotation and can make your game feel more responsive and polished. Quaternions are a mathematical concept used to represent rotations in 3D space, and Unity's implementation of quaternions allows for smooth and efficient rotation calculations. Unlike other rotation methods such as Euler angles, quaternions do not suffer from gimbal lock, which can cause unexpected and erratic behavior in your game objects. Furthermore, quaternions can be used for more than just rotations. They can also be used to interpolate between rotations, allowing for smooth transitions between different orientations of game objects. This can be particularly useful for creating smooth camera movements or character animations. Let's have a recap on what are vectors and quaternions in Unity 3D. Vectors are mathematical objects that provide developers with the control needed to move, rotate, and position game objects smoothly. Unity's built-in functions use vectors such as Vector3.lerp, allow for seamless interpolation between two positions over time. Quaternions are a mathematical tool for representing rotations in 3D space that Unity uses for efficient and smooth rotation calculations. Unlike other methods, quaternions do not suffer from gimbal lock and can cause unexpected behavior in game objects. Now let's move on to discuss about game objects and transform. In Unity, a game object is the basic building block for creating game objects or entities. It can represent anything in the game world, such as a character, a collectible item, an obstacle, or even a light source. The GameObject class provides a wide range of commonly used functions that can be utilized by game developers to manipulate and interact with game objects. Let's have a look at those functions. Instantiate. With this powerful tool, the developer can easily spawn new instances of prefabs or game objects with just a few lines of code. And the best part is that they have complete control over the position, rotation, and parent of newly created objects. Whether they need to create new coins, power-ups, or any other type of object during gameplay, the instantiate function is an essential tool in your game development toolkit. Destroy. The destroy function is an incredibly useful tool in game development that allows you to dynamically destroy game objects or components during runtime. With the ability to specify a delay time, this function can be used to create stunning visual effects or clean up unused objects to optimize performance. Imagine having the power to create an epic explosion that destroys a building or vehicle in real time, or being able to remove a component that is no longer needed in your game. With the find function, the developer can easily locate the exact game objects you need with just its name. No more wasting time scrolling through your hierarchy or searching for it manually. The getComponent and getComponents function offer a seamless solution in accessing and referencing components quickly and efficiently. By using getComponent, the developer can effortlessly obtain a reference to a single component of your desired type, while getComponents function let them access all components of your chosen type with ease. SendMessage is a little gem that can be utilized to elevate the game to new heights, allowing you to respond to events or interactions in real time with dynamic and engaging content. With layer and tag operations, the developer can streamline collision detection, perfect object identification, and elevate your game mechanics to the next level. There is no doubt that the transform component in Unity 3D is critical to the success of your projects. By storing and manipulating the position, rotation, and scale of your game object, it lays the foundation for everything else in your game. That's why understanding the commonly used functions and examples for game object and transform is crucial for any Unity 3D developer. Here are some commonly used functions of the transform class in game development with examples. Translate. The translate component allows you to effortlessly and efficiently move game objects either in world space or local space using a specified direction and distance. By using this powerful tool, you can streamline your workflow and create amazing games with ease. Rotate. With the ability to rotate objects in both world and local space around any desired axis and angle, the developer can fully take control of the game environment and create a truly immersive experience for the players. Scale. With the scale function, the developer has the power to uniformly or non-uniformly scale any game object in local space. This feature opens up endless possibilities for creativity and customization in the game development process. With the parent and child operations function, the developer can effortlessly manage hierarchies, transform the objects, and establish meaningful relationships between them. Look at this exceptional feature offers the ability to effortlessly rotate the game objects toward any designated target position. Now that we have discussed about game object and transform components, let's look at a recap. The game object is the fundamental component in Unity for game objects or entities that can represent anything in the game world. It provides a structure for defining the properties and behaviors of these objects, including their position, rotation, scale, and components. The instantiate function allows you to create a new instance of a prefab or a game object at runtime. The destroy function allows you to destroy a game object or a component at runtime. The find function allows you to find a game object with a specified name in the scene. The get component and get components function allows you to access components attached to a game object. The send message function allows you to send a message to a game object or its components. The game object class provides functions to set, check layers, and tags a game object. The transform component in Unity 3D is responsible for storing and manipulating the position, rotation, and scale of a game object. The translate function allows you to move a game object in world space or local space along a specific direction and distance. The rotate function allows you to rotate a game object in world space or local space around a specified axis and angle. The scale function allows you to scale a game object uniformly or non-uniformly in local space. The transform class provides functions for setting and accessing the parent and children of a game object, which can be used for managing hierarchies, transformations, and relationships between your objects.
Thank you, Shriyams, for the detailed walkthrough of the module. With this, we have come to an end of the 8th module, and I hope you enjoyed it. Stay tuned for your HP Learning Assessment so that you can be certified and start your career in game development. Thank you for joining us.